Hello everyone, I hope you all are good and you all are practicing problems. Let us for now look at this question and what is said in here. In a double slit experiment, a parallel beam of light strikes the slit plane at an angle theta as shown in the figure. So parallel beam of light is just striking slit plane in this way. Okay, so it is making an angle theta with it. But normally when we deal with common YDAC setup, in there we use parallel beams of light like this. Done it? So what is the difference that this direction of light, which is making an angle theta with the slit plane, is going to add to this question? That is what first we need to explore. तो चलो एक काम करते हैं इसको समझने के लिए we will take the help of wavefront. So if rays of light are like this coming from infinity, then you know that wavefront will be what? It will be planar. Done है? So एक ऐसा plane बना लो आप. Done है? This is the wavefront. Done it? And there is one very important thing that direction of light will be always perpendicular to the wavefront. So it is right. And I mean everywhere we cannot draw this plane. इसलिए मैं wavefront को indicate करने के लिए I will be simply using this straight line. And we will draw the straight line in such a way that this always will be perpendicular with the direction of light. Okay. So यहाँ पे अगर आप देखो then wavefront is like this. Okay. It is like this. And if you say this slit, let's say this is slit S1 and this is slit S2. So this particular wavefront will strike slit S1 and S2 at the same time. Right? So same time में strike कर रहा है, but let us check over here. यहाँ पे आप बनाओ सबसे पहले तो wavefront बनाओ such that it will be perpendicular. Let us take the wavefront which is just striking slit S1. So it is this wavefront. Done है? Let us focus on this wavefront. Done है? So at time t equal to 0, let's say it is a striking slit S1. So it will strike slit S2 further after having traveled this much distance, right? Done it? So after some time it will do. So basically, when light will come out from slit S1 and S2, there is path difference already incorporated between these two lights because of the way they travel to the slit position S1 and S2, right? ऐसे हमने जनरली जो हमने पढ़ा है पाथ डिफरेंस कम्स बिकॉज ऑफ ट्रैवलिंग इन दिस स्पेस सो अगर यहाँ से ये ऐसे ट्रैवल किया यहाँ से ऐसे ट्रैवल किया देन बिकॉज ऑफ दिस I mean, this is geometrically less and this is greater, right? So part difference is this much. So we generally calculate optical part difference, which is nothing but mu into geometrical length. Okay. So basically, यहाँ पे part difference दोनों light के बीच में क्यों आया? Because of the way they have traveled in this space. But इस केस में क्या हो रहा है ना? Before they start traveling in this space, there is certain value of part difference already between these two lights, and that is because of this thing. Okay. So ये हम calculate करने की कोशिश करेंगे. आप यहाँ पे देखो. Let's say this is delta x. And this angle is will be how much? This theta angle is between slit plane and the direction of light. So this line is direction of light, this is slit plane, this is theta. So if you see carefully, this is 90, this is theta, this is delta x, and this is slit separation d. So delta x by d will be equal to how much? This is going to be cos theta. So delta x is equal to how much? D cos theta. ठीक है. सो ऑलरेडी इसके पास पार्ट डिफरेंस है. ठीक है. जब यहाँ से लाइट ऐसे निकला जस्ट एंड यहाँ से निकला, then they are already sharing certain part difference, and that is delta x is equal to d cos theta. This is the thing. Okay, let us complete the question. The two slits are covered with transparent plastic sheets of equal thickness t, but of different refractive indices 1.2 and 1.5. So in the path of first light and in the path of second light, sheets are kept. Okay, for now we are not sure here 1.2 one is here or 1.5 one is over here. We don't know this. So let's keep it separate for now. The central maxima is formed at the center of a screen at C. So central maxima C position पे ही बन रहा है. So for that, first of all, we have to figure out which seat was used to cover the slit S1. तो आप ध्यान से देखो, जैसे यहाँ पे लाइट आ रही है, ठीक है? इस स्लिट की बात कर लो. So यहाँ से जो लाइट आई ऐसे, and from here light is coming this way. So in this space, let's say we are dealing with vacuum. Okay, so when there was no seat, just imagine there is no seat. So चलो मैंने इसको हटा दिया यहाँ से, and in this case what you will say लेट से दिस इज लाइट 1, दिस इज लाइट 2. सो लाइट 1 का पाथ लेंथ आप क्या बोलोगे? लेट से दिस लेंथ इज L एंड दिस लेंथ इज L. सो लाइट 1 को आप बोलोगे कि ये L लेंथ कवर किया, एंड लाइट 2 को आप क्या बोलोगे? लाइट 2 तो लाइट 1 भी बहुत सारा डिस्टेंस कवर किया है. सो लाइट 1 और लाइट 2 के बीच का जो डिफरेंस है उसको आप लाइट 2 में ऐड कर लो. सो L प्लस हाउ मच एक्स्ट्रा डिस्टेंस इट हैज ट्रेवल्ड इन दिस स्पेस, that is equal to d cos theta. So this is L plus d cos theta. अब देखो यहाँ पे तुमने रखा सीट. सो सीट को रखने की वजह से क्या होगा? अब फिर से लाइट 1 के लिए आप लिखो L1 के लिए. सो दिस t length of this space along the direction of light is getting occupied by refractive index, let's say mu1. Done है. So L minus t space is in the vacuum. So whatever length is in vacuum, for that geometrical length and optical length will be equal. क्योंकि optical length क्या होता है? mu times geometrical length. अगर vacuum में है ये most of part of this space, then we will say that mu is 1, so geometrical length is equal to optical length. So L minus t portion जो है ना, उसके लिए ऑप्टिकल लेंथ भी L माइनस टी है. अब T के लिए देखो ऑप्टिकल लेंथ क्या होगा? सो फॉर दिस ऑप्टिकल लेंथ इज हाउ मच? म्यू 1 टी. सो यहाँ पे म्यू 1 टी. सो L1 इज ट्रेवलिंग दिस मच डिस्टेंस. ओके. L2 देखो कितना डिस्टेंस कवर करेगा. सो अगेन यहाँ पे भी एक स्लिट है. सो L माइनस टी इज गेटिंग कवर्ड इन द वैक्यूम. सो L minus t plus mu 2 to t is getting covered in media of refractive index mu 2. So it is this plus d cos theta. ठीक है. And in order to get central maxima at this position, what you will expect? You will expect that their path difference is 0, right? So आप इसको माइनस कर दो, या फिर L1 L2 का जो भी डिस्टेंसेस है ना उसको आप इक्वेट कर लो. सो इफ यू इक्वेट इट, यू विल बी राइटिंग L minus t plus mu, this is how much? Mu t, mu and t, right? And this is equal to how much? Let us write it. Mu 2t plus d cos theta, and this is L minus t plus mu 2t plus d cos theta. ठीक है. सो दिस इज दिस. अब आप यहाँ से इसको कैंसिल कर लो. सो म्यू 1 माइनस म्यू 2 t is equal to how much? D cos theta. So D cos theta is what? This is a positive quantity. This has to be positive, right? And here in this space we have taken what? Mu 1. Am I right? Yeah. And in this space we have taken as what? In this space we have taken as mu. See, refractive index to be mu 2. ठीक है. So this is, if this is positive, this also has to be positive, and this is only possible if mu 1 is greater than mu 2. So in that case, what you're going to do, here you will be keeping seat of refractive index 1.5, and here you will be keeping that of refractive index 1.2. So this is sorted, right? Now let us focus on second portion, find theta. So if you have to calculate theta, you can simply do over here. Mu 1 is 1.5 minus 1.2 into t is equal to d cos theta. So cos theta is how much? This is going to be 0.3 t, that is 3t by 10, and then d will come down. So 10d. This is this. Okay. So theta को आप क्या लिखने वाले हो? थीटा को आप लिखोगे cos inverse 3t by 10d. This is going to be our answer. Okay. So I hope you have understood the problem, but if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye-bye.